Hi guys, in this video I'm going to talk about activation function. Before we begin to the activation function, first we know that how this activation function receives the input. So a unit collect information provided by other unit to which it is connected with weighted connections are called synapses. We have a sets of neurons. These neurons have synapses. Each of these synapses receive inputs, and these inputs, when are processed through a neuron, are passed as a output, which is again input for the another synapses. That is, a unit collect information provided by other unit. Here are the synapses. These are connected to other units and other units to which it is connected, and weight connection are called synapses, and they have this weight, and this weight connections are called synapses. Positive weight is considered exotic and negative weight are considered inhibitory. Suppose we have x1, x2, x3 and so on are inputs to artificial neurons. X1, x2 and these are inputs to our artificial neurons, and W1, W2 and Wn are weight attached to the input links. We have this input, and each input has some weight associated with it, which we consider W1, W2, W3. Then the total input I can be represented as I is equals to W1 into X1 plus W2 into X2. This X1, X2 are our input, and W1 are the weight associated with this input, and we calculate this total input I as sum of W1 X1 plus W2 X2 and so on up to Wn Xn, which we can write as I is equals to summation from I is equals to 1 to n Wi into Xi. This is our input, or we have talked about adder. So this is the adder function value. Now to generate final output y, sum is passed on to a non-linear filter called activation function or squashing function, which releases output y. We have this input, that is sum of all the inputs. Now this input is passed to another function or filter that is called as activation function or squashing function, and now this activation function will now finally release the output y. A commonly used activation function is thresholding function. The sum, that is our I, the sum of total inputs, the sum is compared with a threshold value theta. We compare this sum value with a threshold value theta. If output I is greater than theta, then output is 1, else 0. Suppose our value of the I is 0.9 and we say this value is greater than, suppose we consider theta as 0, we can consider theta, that is our threshold value. It varies according to the question. Suppose we have theta value as 0. If sum of the value is greater than theta, that is 0, that is 0.9 is greater than 0, then we can say output is 1. And suppose we have this value I minus 0.1, that is it is less than 0, then we will give the output 0. That it can be written as y is equals to f function of I minus theta. All the neurons in the same layer have same activation functions are used. That is, all the neurons which are at the same level, then same activation function will be used for all the neurons. So this was all activation function. Thank you.